Hi everyone, I'm Christina and welcome to video 10 in our A-level mathematics calculus series. In this video, we're differentiating expressions with powers of x, and this is part 1. So our objectives in this video are just to introduce formulae for differentiating powers of x, and we have two special cases. The main one we're going to look at here is to recognize that the derivative of a constant function, that's a function where f of x is equal to a constant number a. When we find the derivative of a constant function, we always get 0. So let's have a look at the formulae here. So if n is any real number and a is a constant number, for f of x in the form f of x equals x to the power of n, if we want to find the derivative of that function, f dash of x, we bring down the n. So we bring down our power n in front, which becomes our coefficient for our derivative. And then we minus 1 from the index, which we have here. So that's the general formula we follow when we have a function in the form of x to the n. Now, in our second formula here, we have a function which is a times x to the n. So we have a coefficient of a in front of our x to the n. So when we want to find our derivative function, we keep our constant a in front, and then we just differentiate our x to the n as we did before. So what happens is we bring down our n in front. That's why we get our a times n here. And then we minus 1 from the index up here. In our third formula here, if f of x is a to the x, so our function here is x to the power of 1. So it's just x. We have our coefficient a. If we want to find the derivative, f dash of x of this function, it's just a. It's just the constant in front of our x. And our special case here, when our f of x is a constant value, a, so that's any constant value, the derivative of a constant function like this is always 0. So in the next video, we're going to apply these to some worked examples.